Welcome to this video on how to run a Pearsons correlation test. I'm going to show you how to do this test in two different softwares, one in Excel, which is the easier version, and two in SPSS, which is slightly harder, but only because there's a few more steps that need to be taken in terms of telling SPSS what your data means. So to start with, in Excel you should recognize this data straight away. Okay, so this is all the VO2 max testing we've been doing over the last few weeks, doing the Cooper run and the Astron cycle test. Okay, both estimation tests in which we would anticipate getting similar results. So the first thing I've done with my data is I have run averages and standard deviation tests, as you can see down here. Again, I've highlighted it just so it stands out from the crowd and I can see straight away they're my descriptive statistics, at least I can say it. The first thing you should notice really is that the averages are quite far apart from each other, considering they're both supposed to estimate VO2 max. Now obviously we wouldn't expect that if they're both valid and reliable. However, there's obviously an issue and we need to find out what it is. Okay, so in your assignment I expect you to be questioning why these results aren't the same. Now, to run a correlation test to find out whether there is a relationship between the two tests, we need to do the following. Highlight a cell in which you want your R score to be placed in, equals Pearson, open your brackets, and you'll see here array 1 is highlighted. So array 1 is my Cooper run data. Okay, so I'm going to highlight all of that. Again, please don't highlight the descriptive statistics in this, just the raw data. Add your comma in and go to array 2 and highlight that data as well. Once you've done that, click enter, and your R score is 0.21632. Okay, a very simple test to perform. That is it, and you have an R score. Now that's all well and good, but what does this R score mean? Well, in a Pearsons correlation test, your results range from -1 all the way up to 1. Okay, so across the range, the closer your R score is to -1, the stronger negative correlation you have. The closer your score is to +1, the stronger positive correlation you have, and the closer that score is to 0, then there's no relationship. Okay, now to look at some boundaries of what the numbers actually mean, we can use this here. Okay, so you can see here, the closer it is to 1, we've got a very strong positive correlation. The closer it is to -1, a very strong negative correlation, and if it falls within or around 0, then we have no relationship. Okay, our score, okay, is 0.21632, and therefore will fall within weak positive relationship. Okay, so that's important. All right, that needs to be put inside your assignment, and that also needs to be explained. Okay, what does your R score mean, and why is that the case? Okay, so a very simple test to perform in Excel. For those of you who want to get to grips with SPSS, then we're going to do that in SPSS as well. Now, this is what I ran earlier. I'm trying to close it. 1 second. Okay, so I can go through the process with you again. Okay, so my data I have in SPSS. This is the face of SPSS, and for those of you who haven't seen it before, then welcome. Okay, at the bottom here you can see there are two views. We have the data view, which is what we're currently on, and a variable view. Okay, so the first thing I've done here is I've copied my data over from Excel, straight copy and paste, just my raw data, the Cooper and Astron, and put them into the first two columns. Now the difference, or the big difference between Excel and SPSS, is that in Excel you can kind of set your data up how you want. Okay, columns and rows don't really need to be set in a certain way, whereas in SPSS the columns and the rows are important. Okay, in every column you have a different factor. Every row represents an individual person. Okay, so it's not so bad for the data we have now, but if we were to have multiple groups of different people, we would need to set them out down in different rows. Okay, but thankfully this data doesn't need to do that, and therefore it's slightly easier. So for every row here, 1, 2, 3, 4, 5, etc., that represents a single person. Okay, now once I put my data in, I had to go to variable view, which is where we tell SPSS what our data means. Okay, the first thing I've done then is I've given each of my variables a name. So Cooper Run for Cooper Run and Astrand for Astrand. Fairly simple. The next column represents what type of data it is. Okay, if I click on this blue square, I've got lots of options. The numbers in there are obviously numeric, and we just leave it as numeric. If we had words in there, we could change that over, but we don't, so that's good. Width, the default is 8 and 2. The width basically means how many numbers wide you can see, and the decimal places obviously how many decimal places you can see. There's no real need to change them unless you had a number that was longer than 8 figures long, or you had a number that you want to see more decimal places. For us, we don't need to see that. I've given each of my variables a label. Okay, so I'll put in there VO2 max, that's what the result, what the number means, and the units that it was calculated in. Okay, so if I come back to this data set in 6 months time and I'm a little bit unsure on what Cooper and Astrand actually mean, I can look at the label and that will help explain a little bit better to me what the numbers mean. Okay, if I had different groups, I could give each group a number, but I don't have that, so I'm going to leave values empty. I don't have any missing variables. I don't need to do anything with column, just leave it as default. The alignment is where the number sits within the cell itself. That's personal preference. It's defaulted to the right. There's no real reason to change it, but it is entirely up to you. You can have it on the left or in the center. Finally, the measure. Okay, this is important because if you don't get the measure right, then the test won't go correct. Okay, so you've got the choice of scale, ordinal, or nominal, and for the sake of this argument, we are looking at scale data. Okay, now let's move back to data view. So to run the Pearsons correlation test, you need to go up to Analyze, go down to Correlate, and Bivariate. Okay, so you can see here what you will see when you go into it is actually your variables to the left hand side. I've run this test once already just to make sure it worked, so I'd already put my variables across. You will come to a screen that looks like this, so highlight your two variables here and move them across. Okay, click on options and make sure that means and standard deviations are ticked, because you want some descriptive statistics to look at when you get your output. Click continue and ensure that Pearsons correlation coefficient is ticked here. Once you've done all that, click OK and you will get your output from SPSS. Now, there's a few things we can see here. The first box is our descriptive statistics. We have our means and standard deviations here for each group. Okay, so if we were to compare them back to Excel, then we should see the same. So for the Cooper Run test, we've got 35.73, which is there, 43.9 for the Astrand site, which is underneath, and we have 11 and 9.4 for standard deviation. So we've got everything correct there, and we have 27 people in each group, which is exactly the same as Excel. So nothing's changed there. Okay, each are as good as one another in terms of descriptive statistics. Oh god, tongue tangler. Descriptive statistics. Now, the difference being in these two tests is that SPSS is slightly more accurate in terms of its Pearsons correlation test, and we can trust it a little bit more because it also gives us a significant two-tailed hypothesis p-value, okay, which is well worth representing within your results section of your assignment. Okay, so we can see over in Excel we have a score of 0.2632, and we do have that over here as well. Okay, so we can see that we have a very weak positive correlation. Okay, again, looking back on our guidelines over here for our R value, we can make that assumption. Let's go back to our results. Okay, now what we do see as well is a significant two-tailed value here. Now remember that the p-value, if it's significant, it is below 0.05. If it is non-significant, it is above 0.05. Okay, so although we have a weak correlation here, positive correlation, we can assume based on the significant value there that that is insignificant. Okay, so there's a lot to talk about there, and there's a lot to think about in your assignment. But that is essentially how to do a Pearsons correlation test, one in Excel and two in SPSS. Okay, and also how to interpret them. So I hope that really helps with your assignment, and if you have any questions, please come and see me.